All right, let's head out to the far reaches of our solar system because we're going to dive in to a genuine cosmic mystery. Why are the magnetic fields of Uranus and Neptune so strange? We're going to explore a really fascinating and definitely unconventional theory that suggests we need to rethink the very physics of how our solar system works.
So here's the problem in a nutshell. You look at a planet like Earth or even a giant like Jupiter, and their magnetic fields line up pretty nicely with the way they spin. But Uranus and Neptune? They're the odd ones out. Their fields are tilted by a huge amount, and they're not even centered inside the planet. They're way off to the side. The big question has always been, why?
Now, the standard explanation is that there must be some kind of weird, slushy ocean deep inside these planets, and the fluid motions are creating these odd fields. But the source material for this explainer basically throws that idea out. It calls it guesswork, relying on pushed computer models with zero data to back them up. And it's that skepticism that really opens the door for a completely different approach.
Okay, so before we can even get to Uranus and Neptune, we have to understand the foundational idea of this whole theory. And it all comes down to a concept the author calls the charge field.
So what is this charge field? Well, according to this theory, you have to imagine that our entire solar system is swimming in this constant ambient field of photons. This means a planet's magnetic field isn't just generated from its own core. No, it's actually an interaction between the photons the planet emits and this external field that's already there. It's a two-part equation, not a one-part one.
The theory then redefines how magnetism itself works. It's pretty simple, actually. A photon's forward motion, its path through space, creates an electrical field, but its spin, that's what creates the magnetic field. And here's the absolute key, the one rule you have to remember for all of this to make sense. Those two fields, the electrical and the magnetic, are always at a perfect 90-degree angle to each other. That's the master rule.
To get a feel for that 90-degree rule, just think about a spinning top. If you try to slide it across a table, you feel that spin fighting you, right? You feel its sideways motion and its spin force. But if you just lift it straight up or down, you don't really feel that spin force pushing against you. It's because the force is in the wrong plane. That's exactly the relationship this model proposes between motion and spin.
Okay, so we've got the rules of the game. Now for the fun part. Let's apply this and see if we can solve the first mystery. Why is Uranus knocked over on its side?
So here's how it's supposed to work normally. A planet's equator naturally wants to line up with the sun's huge, flat electrical field. It's the most powerful thing around. But Uranus, this theory says, is stuck in this incredibly unlucky spot. It's caught in a cosmic tug-of-war between the tilted electrical fields of its giant neighbors, Saturn and Neptune.
Now, I know what you're thinking when you see this chart. You're saying, wait a minute, the sun's influence is way, way bigger. Why wouldn't Uranus just listen to the sun? And that's a great question. According to the theory, the sun's field sets the baseline. It defines the flat plane of the solar system. But the actual tilting force comes from the local environment, from the skewed fields of Saturn and Neptune, which happen to have pretty significant tilts of their own.
So here's the chain reaction, step by step. 1. Saturn and Neptune are already tilted. 2. Their tilted fields combine to create this weird, skewed local field right where Uranus is. 3. Uranus, just trying to align itself like any other planet, latches onto that powerful local field instead of the sun's. And the result? It gets pulled almost completely over onto its side.
And get this isn't just a vague idea. The theory actually puts a number on it. It calculates that, based on the tilts of Saturn and Neptune, their combined influence would add about 16.5 degrees of tilt to a 90-degree baseline. That gives you 106.5 degrees, which is incredibly close to what we actually observe.
All right, so that's the planet's tilt explained. But what about the magnetic field itself? Let's dig into that next.
This model says Uranus has a quadrupole character. Now that's just a fancy science term for being caught between two different competing electrical fields. You've got the main flat field from the Sun and Jupiter on one hand, and then you've got this weird tilted local field from Saturn and Neptune on the other.
So you've got this magnetic tug-of-war happening. The stronger field, from the Sun and Jupiter, is trying to create a normal magnetic field that lines up with the planet's spin. But at the same time, that weaker local field from Saturn and Neptune is trying to create a second magnetic field, one that's aligned with the planet's tilted equator. The bizarre, messy, warped field we actually see is just the result of these two forces fighting it out.
Okay, but why is the field so off-center? The theory has an answer for that too. It suggests that the solar wind, which is incredibly powerful out there, is actually strong enough to physically push on that weaker secondary magnetic field. It essentially blows it back, shoving the whole magnetic axis away from the planet's physical center.
So after building this whole detailed case for Uranus, the theory says that explaining Neptune is actually the easy part. It's just the next domino to fall.
The logic here is pretty straightforward. Uranus, which now has its own powerful, tilted, and off-center field, becomes the new dominant local influence for Neptune. So, Neptune finds itself in the exact same boat Uranus was in, caught between the Sun's normal field and a really weird local one. And, you guessed it, the result is the same. Another messy, tilted, off-center magnetic field.
The author wraps all this up with a really provocative thought. These extreme tilts aren't some stable, ancient feature of our solar system. Instead, they're seen as proof of an ongoing instability, a sign that the electrical and gravitational dance of the outer planets is anything but settled. To quote them directly, our solar system is a time bomb.
And that really leaves us with the big question to chew on. This whole theory is built on a fundamental shift in how we look at things. So what happens to our understanding if we start to see the solar system not just as a bunch of objects held together by gravity, but as this complex, interacting electrical system? It's a fascinating new lens to view the cosmos through. Thanks for joining me on this one.